Dear students, in this session we will discuss about principle of superposition. Principle of superposition. See, now what we are going to discuss? We are going to discuss about principle of superposition. According to the principle of superposition, first we will understand the concept and after that I will give the definition. For example, for example here sun is there here. This one is sun. I think sun is in red color, right? Here sun is there. Sun. So now we are going to calculate the total force acting on sun. We are going to calculate the force acting on the sun. See here, for example, here one planet is there, green planet, nothing but Earth is here. Earth is here. So now, in between the two, force of attraction is there, right? So I will write this one as in this direction, that is F, sun and Earth. Sun and Earth. Not only Earth here, one more planet is there. For example, that planet is this one. Here the planet is this one, blue planet. So now on this one, in between the two, the force will be in this direction. That is F, let it be, we will write this mass. So it is M and E. So now if you see in this situation, on sun, two forces are acting. So ultimately what we have to calculate? We have to calculate the total force. Total force is nothing but the net force acting on the sun. If you want to calculate the net force acting on the sun, we know already force is a vector quantity. Force is a vector quantity. So what we have to do? We have to apply a vector quantity and we have to solve the net force, F net. So here only two particles are there, or one is earth is there and second is mass is there. No, n particles are there. For example, here if you see the normal situation here, I wrote here one mass m is there, and here m1 is there, m2 is there, m3 is there, so on, mn is there. How many particles are there? N particles are there, mn particles. So in this situation, if you want to see the force will be in this direction. I will write this is F1, but because here M1 is there, that's why I wrote it is F1, it is F2, and it is F3, and so on. Here it is Fn. So here n number of forces are acting on the mass capital M. If you want to find out the total force, we have to apply the vector addition. We have to apply the vector addition. That is nothing but principle of superposition. Principle of superposition. According to principle of superposition, the total force acting on a body, due to the remaining body or the remaining bodies. I hope you are understanding, right? According to principle of superposition, the total force acting on the body due to the remaining bodies is equal to the vector sum of the individual forces. It is not the algebraic sum. It is not an algebraic sum. I am saying that it is a vector sum. It is equal to the vector sum of the individual forces. Now see here, I will write the definition here. See, I will write the definition here. According to principle of superposition, the total force acting on a body due to the remaining masses is equal to the vector sum of the individual forces. According to the principle of superposition, the total force acting on a body, due to the remaining masses is equal to the vector sum of the individual forces. That means here I will write F net can be written as F1 bar plus F2 bar plus F3 bar plus so on. So here n number of forces are there. We have to add. How to add? It is not the algebraic sum, it is the vector sum. So make a note. Now we will see how to solve the total force. We will do 2-3 numericals. Based on that, we will try to understand. See, for example, here I will write question number 1. He is given that only for understanding purpose only, small numericals we will try to understand, right? So here, question number 1, here 2 masses are there. For example, here M1 1 kg and here it is M2 2 kg. Distance 10 meters. Distance is how much? 10 meters. He is asking that find the force acting on each other, or find the force acting on one due to other. So already we know the force acting this one or here, or the force acting due to this one on this one should remain same. So in this situation, if you want to calculate the force, I will write F is equal to G M1 M2 by R square. So F is equal to G, we know 6.67 into 10 power minus 11 into M1 is given as 1, M2 is 2, upon R is nothing but 10 here, it is R square 10 square. So here F is equal to 6.67 into 2, I will write here 10 power minus 11. This is 10 power 2, 10 power 2, it will go up, it becomes 10 power minus 2. So here F is equal to, we will multiply these two, we will multiply, how much we will get? 13.34 into 10 power minus 13 Newton. This will be the force. This will be the force. Clear? Clear? A basic numerical when two bodies are separated by distance r. So how to calculate the force between the two? This one. Now we will see one more question. Here itself we will try to understand. Question number 2. Question number 2. Here again one mass is there. M1 1 kg. Only for understanding purpose I am taking the values. Don't think every time why R is taking 1 kg, 2 kg, 1 kg, 1 kg. Why? Because to make the numerical small simple. Because here I don't want to show the calculations part, right? So I will consider only some smaller values so that it will easily cut off. Clear? See here. Here M1 1 kg. Here M2. This one also 1 kg. Here it is M3. Also 1 kg. Here how many masses are there? 3 masses are given. And here M1, M2, M3 all are identical masses of having mass. How much it is? 1 kg. And distance also I will write here. It is 1 meter, 1 meter and 1 meter. Now he is asking that the force acting on M1. What he is asking? Find the force acting on M1. See here. Find force acting on M1. Find the force acting on M1. So now we will try to understand. We know already 2 particle system is how to solve. 2 particle system is how to solve. Now we are trying to understand the 3 particle system. In 3 particle system, 3 masses are given. So how to find out the force? So now what is our target? We are going to find out the force on M1. So when you see here, many times students will confuse how to identify the direction of forces. How to identify the direction of forces. Please try to understand here. So here M2 is there and we are calculating force on M1. Force on M1. Due to M2, M1 is attracting towards M2. Due to M2, M1 is attracting towards M2. So attraction will be in this direction. Clear? So I will write this force is F12. How much force is F12? Why? Because force acting on 1 due to 2. Clear? It is towards M2. Why? Because M1 is attracting towards M2. In the similar manner, if you see third kg, 3 kg. So here also M3 is attracting M1. M3 is attracting M1. So the direction of force will be in this direction. Direction of force is in this direction, and then this is F13. Force on 1 due to 3. Now what we have to calculate? We have to calculate the total force. Total force is nothing but the net force. Net force acting on M1. The net force acting on M1 will be this direction. F net. So now you tell me how to solve. So this is an equilateral triangle. Equilateral triangle means this one 60 degrees, this one 60 degrees, and the angle between F12 and F13 is 60 degrees. So when two forces are acting by making an angle theta, we know how to calculate the resultant or net force. How to calculate? We know general formula I'm writing. F resultant square is equal to F1 square plus F2 square plus 2 F1 F2 cos theta. In vectors, maybe you studied here, right? What is the resultant formula? Resultant Fr square is equal to F1 square plus F2 square plus 2 F1 F2 cos theta, where theta is the angle between the two forces. How much here? It is 60 degrees. Now first our target to find the value of F12 and F13. F12 and F13. So see how to solve. Here I will write here F12 is equal to, what is the formula for F12? What is the formula for F? G M1 M2 by R square. I will write G. What is M1 here? 1. And M2 is here, how much is 1? By R square. Distance is how much? 1. So it is 1 square. Clear? So I will get here, I will get G value I am getting. I hope you are understanding, right? That's why I wrote here 1, 1, 1. So in order to make easy questions, we got F12 is how much? G. Again, similarly, F13 you calculate. F13, force between these two. Force between these two. Tell me, G, M1 is 1, M3 is also 1, upon distance how much it is? 1 square. So again you are getting G value. So now here these two forces are remain same. That means here in this situation F1 and F2 remains same. So now what we are going to calculate? We are going to calculate F net. So we will see how to calculate F net. So here F net square can be written as the same formula. What is F1 here? G. So G square plus what is F2? F2 is also G. So I will write here G square plus 2 F1 F2 2 G cos theta. What is cos theta? What is the angle here? Theta is equal to 60 degrees. Theta is the angle between the two forces. The angle between the two forces you have to calculate, right? So here it is 2 G1 G2 cos 60. What is cos 60? Cos 60 1 by 2. Very good. So here F net square can be written as G square plus 2. This is G square. Cos 60 means 1 by 2. 1 by 2. So this 1 by 2, this 2 will get cancelled. So G square plus G square plus G square, 3G square. 3G square. Am I clear? G square plus G square plus G square is equal to 3G square. And I will write here resultant force F net square can be written as 3G square. That implies I want to find out the net force. F net I want to calculate. F net. So F net can be written as, here square I am removing, here I will get root of 3G square. So here F net can be written as G root 3. How much you are getting? F net is equal to G root 3. I hope you are understanding, right? Very small topic. And mains point of view he will not ask. Mains point of view, maximum time he will not ask. But NEET point of view he will ask. So whenever I am saying these words, okay, mains point of view, NEET point of view. So if you are following NEET, so you make a star mark. And if you are following mains, So just to hold it. Am I clear? But important concept. According to principle of superposition, the total force acting on a body, is equal to the vector sum of the individual forces. I hope you understood, right? Make a note. See one more question. I'm not going to discuss all the questions here. Only different concepts only I will try to explain here. See one more question. You will ask like this. Question this one. Here one mass is there, m1. This one is I will write m2, and this one is m3, and this one is m4. Now here in the last numerical, what we seen? We seen three masses are there. Now here 4 masses are there. This is a 4 particle system. Now we are going to find out the total force. For example, here where we will consider here, we will try to find the force on M3. So the question is find F net on M3. Find F net on M3. So now again we have to identify the directions. Only first important point is we have to identify the directions. Based on the directions we have to follow. Clear? Now see this one. See here. First I will see we are calculating force on M3, right? So in between these two, attraction force is there. So M3 is attracting towards 2. Simply I will write it is F2. M3 is attracting towards 2. Correct? Now in between M4 and M3 also, M3 is attracting M4. So here you will see here this force. Correct? I will write this is F4. Only these are the two forces or any other force is there? These are the two forces or any other force is there? Yes, one more force is there. In between M1 and M3. M1 and M3 also, M3 is attracting towards M1. So if M3 is attracting towards M1, the direction will be this one. See here. The direction will be this one. This force. This is F1 I will write. Clear? So here on M3, 3 forces are acting. One is F2, second one is F4, and third one is F1. So now we have to calculate individually, and after we have to apply vector additions. Right? So one thing we have to understand here, only for this particular question only, but because M1, M2, M3, M4 now, in the question for example let it only 1 kg. So M1 is equal to M2 is equal to M3 is equal to M4 is equal to 1 kg I am considering. 1 kg. Clear? And again distance between the two, I will write only 1 meter. 1 meter. So if this one is 1 meter and this one is 1 meter, this one is 1 meter and this one is 1 meter. So now you tell me, these are two masses, same masses, distance, same masses, distance. So this force and this force should remain. The force between these two and the force between these two should remain same. Why? Because these two are the same masses and these two are the same masses and separated by the same distance, the force should be same. That means here I can write here only for in this special condition I can write here F2 is equal to F4. F2 is equal to F4. Correct? This force and this force remain same. Why? Because same amount of masses and same distance. That's the force is remain same. So here how much it is? F2 is equal to F4. How much it is? G M1 M2. M1 M2 means only 1 kg. M1 M2 by R square. R is nothing but 1. So I will write it is 1 square. Simply we will get G. Am I clear? Clear? Now you tell me F2 is acting in this direction and F4 is acting in this direction. How to find out the net force? How to find out net force? Tell me. F4 is acting upward. F2 is acting upward. F4 is acting in this direction. So how to find out the net force? Sir, net force only one formula. F r square is equal to f1 square plus f2 square plus 2 f1 f2 cos theta. I will substitute and I will find out the answer. Clear? So here the resultant between these two forces, I am only calculating not the net force. I am not calculating the net force. The resultant between these two forces first I am calculating. You must try to understand. First I calculated F2, I calculated F4. The resultant between the two forces I am calculating. The resultant between the two forces can be written as here F24 I will write, which is equal to F2 square plus F4 square plus 2 F2 F4 cos theta. Clear? That means remain same. See here, this F2 and F4 is nothing but G only. So as we did in the last numerical, so I will write here G square plus 2G cos. Cos, how much angle I have to write? How much angle? What is the angle between the two? Angle between these two? 90 degrees, right? So I will write here cos 90. So we know cos 90 is 0. So this becomes 0. If it is 0, you will get F24 square can be written as G square plus G square 2G square. So I will write F24 is equal to G root 2. What is F24? G root 2. Now you tell me, one force is acting upward, one force is acting in this direction. These two are same forces. If these two are same forces, the resultant exactly the diagonal. Correct? That's why I left some space here. Why? Because due to this F2 and due to this F4, the net force, the resultant force is acting in this direction. In this direction, the force is acting. This force is how much? F24. How much it is? F24. So on M3, the total force is, or the net force is F12 plus F24. F12 plus F24. See here, we will write the total force or Fnet on M3, which is equal to F1 plus F24. F1 plus F24. So we calculate F1. F1 is nothing but again force between these two. See, G, M1 is 1, M2 is 1 by R square. R. Now you have to say what is R? R is nothing but the distance between this one and this one. It is a diagonal, right? It is not 1. So this one is 1 and this one is 1. This one will be root 2. We know already basic maths, right? So if it is 1 and this is 1, this will be root 2. So we write here F is equal to G M1 M2 by R square. G M1 M2 by R square. So root 2 whole square I will write here. Plus F24. F24 already we calculated. How much it is? G root 2. So I will write here this G root 2. So next we will get here G by 2 plus G root 2 will be there. Correct? Now here I will write, see I will write here. So F net can be written as, I will take G and G common here. 1 by 2 plus root 2. 1 by 2 plus root 2. If you want to further simplify, depends upon the options only we have to go, right? So I will write F net can be written as, G 1 plus 2 root 2 by 2. This one also you can write. So in this way, whether 2 particles are given or 3 particles are given or 4 particles are given, we can able to find out the net force acting on the given mass. This one is called principle of superposition. According to the principle of superposition, the total force is equal to vector sum of the individual forces. Total force is equal to the vector sum of the individual forces. Right? I hope you understood, right, this topic. Thank you.